So in this video we'll solve a problem 3 here. Okay, so related to thick cylinders. Okay, so the if you see the problem 1 and 2 and problem 3, you will clearly come to know that the how to solve a problem on the thick cylinders by using the Lec equation. Okay, first we will read the problem here, then we'll try to write the data set. A cylindrical pressure vessel has inner and outer radii of 200 mm and 250 mm. He is given the inner radius and the outer radius of the thick cylinder, 200 mm and the 250 mm. That is inner and outer radii are 200 and 250 mm respectively. So first we will write the data. Inner radii Ri equal to 200 mm. That I can write it at x equal to 200 at a distance of x, because we have to apply Leng's equation in terms of x where you want in the thickness, right? So when x equal to 200 mm, inner radius, and outer radius is out r naught equal to 250, r naught equal to 250 mm. That is also when x equal to 250 mm. We'll check that respectively. The material of cylinder has allowable stress of 75 meganewton per meter square. He is given the whatever the cylindrical material is there, it has an allowable stress of 75 meganewton per meter square. That is allowable stress equal to 75 meganewton per meter square. Convert this into mm square. That will be equal to 75 into 10 raised to 6 divided by 10 raised to 6 Newton per mm square, right? This is nothing but MPa. Okay, this will be equal to 75 Newton per mm square or MPa, both are same. That is sigma allowable. Okay, now as previous two problems we solved here, the inner radius and the outer radius, in which wall the stress is more. If you see that the whatever calculated, and we sketch the picture here, based on that, the inner wall of the cylinder has more allowable more circumferential stress compared to the outside. As the thickness goes on increases, the allowable stress goes on decreases. Okay, finally it will be less values in the outside. So can I write this one as at the inner side? This I can write it as, that will be equal to sigma c at x equal to inner wall at 200 that will be equal to sigma c I at the inner side. Okay, just we will okay, first remaining will read the unknown value. Determine the maximum internal pressure. He is asking you have to calculate the maximum internal pressure that can be applied. What is that? The pressure at inside, that will be equal to pressure at x equal to how much? Inner radius, it is 200 mm, right? At 200 equal to how much he is asking. Next, and draw a sketch. You have to draw a sketch of radial pressure distribution and circumferential stress distribution. You have to draw here. First we'll try to draw a sketch, and we'll try to mark the values which possible values which are given in the data here. Just I'll draw here. This is the inner radius and this is the outer radius. Okay, just a minute. We'll remove the problem here, because all the data we know copied here. Okay, this is the inner radius, this is the outer radius, and this is the center. From the center I'll mark the center line. Okay, this is the center line. Now what is the data is given? When Ri is 200 mm, this is inner radius, this is Ri equal to x equal to 200 mm, this is inner radius. Outer radius is 250 mm, that is R naught equal to x equal to 250 mm. So what is the thickness? 250 minus 200, it is 50 mm thickness of the cylinder. Okay, that is the one thing here. Next, sigma allowable, he is given the sigma c at x equal to 200. at a distance of x from the center, it is 200 means it is inner radius. He is given the inner valve, the stress distribution. Always we are marking the pressure distribution is, we are sketching pressure distribution downside and the circumferential distribution upper side. Okay. Now he is given circumferential stress. We have to mark the upper side, that to inner valve, in the inner valve at 200 mm. At 200 mm is how much is given here? 75. From here, from this point to this point, just mark it the 75. That is sigma Ci equal to 75 Newton per mm square. That is MPa. We mark. Then anything we have to calculate the pressure distribution at inner valve, and he is not given the pressure. If he is not given the pressure at the outside, it is always 0. Here, if you see that this is inner, we have to calculate how much pressure at inner equal to how much we have to calculate. He is given, and the pressure at outside, it will be 0 if not given. Okay. Now apply this, and how to solve the unknown values? We have to go for the Lec equation. Okay. Apply the Lec equation. What is the Lec equation? First one is P at x equal to B by x square minus A, right? One more, circumferential stress at x equal to B by x square plus A here. Okay. Now apply the boundary conditions. Boundary conditions based on the data. When r equal to ri equal to x equal to 200, ri equal to 200, the circumferential stress equal to 75 MPa, right? When x equal to 200, that is sigma c at x equal to 200 is 75 MPa. 75 MPa. That is nothing but sigma Ci, right? Sigma Ci. One boundary condition we found here. Here substitute the 75 MPa when x equal to 200. When x equal to 200. Similarly, when x equal to 250, pressure at outside is 0. This is one more boundary condition. When x equal to, second boundary condition, when x equal to 250, that is P at x equal to P 250 equal to 0. Apply this boundary condition, these two, and try to solve the values of B and A here. Just I am applying here the boundary conditions. First one I am applying here. When x equal to 250, pressure is 0. This is 0 equal to B by x square. B by x is how much? 250. It is 250. 250 square minus A. This is one equation. Call it as, this one is one equation. Equation number 1. Similarly, apply the first boundary condition to here. Okay. When x equal to 200, that is circumferential stress is 75. That is 75 MPa equal to B by x square. B by how much is the internal? That is 200. That is 200 square minus A plus A. This is equation number 2 here. Okay. You have to solve these two equations here. Now solve equation 1 and 2 to find out the A and B value. Solve equation 1 and 2. 1 and 2. You know how to solve. Just make it plus. These two will go, and you will get the in terms of B. Okay. After getting the value of B, try to substitute the value of B in any one equation. Either here or here, you will get the A value here. Okay. I will substitute directly here. From that, we will get the value of A is 29.3. A equal to 29.3 and B equal to, we will get here 1829 268.3 268.3. This is the value of A and B. Always B value will get more. If you see the previous two problems also, B is more and A is less here. Now come to the what we want to calculate here. Pi. Okay. At x equal to 200, how much is the pressure? Okay. Now out in the Lec equation, which we will go here, here this equation. Substitute x equal to 200. Here x equal to 200. We know A value, we know B value, right? We will get the pressure at x equal to 200 here. How much we will get? Okay. And we'll try to solve here. Now from this equation, okay, when x equal to 200, P of 200 equal to B by 200 square minus A. This will be equal to B is how much? 1829,268.3 divided by 200 square minus A. Okay. Now this is nothing but P at I, pressure at I inside, because 200 is inner radius. So substitute and calculate. Minus A is how much? A is 29.3. This is 29.3. Now so calculate here, simplify and calculate. We will get the PI is 16.4 MPa. This will be 16.4 MPa. That is equal to PI. Mark a value 16.4 here, PI. Here, just I'll mark here 16 point PI, the same here. PI equal to 16.4 MPa. Now we can join this and this point. Here P naught is 0, the downside is pressure distribution. Directly we will get the 0. Here more value, more, less, and finally it will be 0. This is how the pressure distribution along the thickness. Now we will come to the circumferential distribution. Inside the valve it is the 75 MPa. From here to here it is 75 MPa. This is also here. Okay. Now we will calculate the circumferential stress at the outside of the wall. Which equation we have to use? Of the lengths, this is second equation. Okay. Now I'll use this equation and I'll calculate here. Okay. So from this one, when x equal to outside we want, when x equal to 250 mm, sigma c of 250 equal to sigma c naught, right? It is outside, equal to, we know B value. B is how much? 1829,268.3 divided by x is at a distance of 250 square plus A is 29.3. Now simplify this one. We will get circumferential stress at the outside is 58.6. If you calculate and simplify, you will get the sigma c naught. This is sigma c naught. Now mark the value on the sketch here, 58.6. This is 75. Obviously it is lesser than the this value, that is here. Sigma c naught equal to 58.6 MPa. Now join these two here. Okay. Now this is how the circumferential stress distribution from the center. Okay. Downside is pressure distribution. This is PI. We are calculated, right? The PI is 16.4. This is 16.4. 16.40, 75 MPa and 58.6 MPa. If you see the picture, the inner side pressure as well as the circumferential stress, it is more. As the thickness goes on decreases, increases their thickness. The finally outer valve, the pressure is 0 and circumferential stress also it will be lesser than the inside valve. This is how the sketch you have to draw that.